All right, we're going to finish factoring by factoring completely. All right, so factoring completely just means that we're factoring until you cannot factor anymore. You took out every single factor and wrote out every single one in whatever polynomial that we give you. All right, so the typical strategy for it, it's written here. I'm going to rewrite it in a way that maybe you guys like to write on your tests and quizzes. I see a lot of you on typically at the start of your test, you guys like to write things down. So I'll make it simple so that it's easy to remember and that you can reference anytime you need. But yeah, anytime you're factoring completely, you may need to factor things more than once. You always want to check for the GCF first. That's always the very first thing that we do. If there's two terms, we're going to check for a special case like a difference of squares or a sum or difference of cubes. If there are four terms, you want to check if we can factor by grouping. And if there are three terms, check if there's anything special about it, like a perfect square trinomial, or if it's something that you could just factor like normal, right? Traditional factoring as we did in the previous lesson. All right, but typically what I like to write and what I've written a couple times in class, I always write the first thing that you check for is the GCF. The second thing that you check for are your special cases. The third thing is, is any trinomials. And then four terms is by grouping. All right, so just a little cheat sheet for you guys to remember. I mean, of course, you guys are going to have to remember these steps, but just something simple that covers all the bases. But just to get a little bit more specific, GCF is pretty straightforward. I mean, just check if there's a common factor between all of your terms. The next thing is special cases. You want to either check if there is a difference of squares. All right. The other special case was a perfect square trinomial. And then the last special case was a sum or difference of cubes. All right. Trinomials, there were only two different kinds of trinomials. Besides the perfect square trinomials, which is your special case, you either have a equals 1 or a doesn't equal 1, right? When a equals 1, it was just traditional factoring. What multiplies to the last adds to the middle. When a didn't equal 1, it was what multiplies to the first times the last and adds to the middle, right? So that was either slide and divide or by grouping. And then the last thing by grouping, if you have four terms, right, that's the only note that I would write on grouping, is if there are four terms. All right, so it's going to be a series of these steps every time, and I'm going to mention over and over again, the very first thing is always the GCF, and then we look for all these other stuff. All right, so let's start with this first one. Factor completely. That's how maybe your quiz is going to look. You're going to get a couple, maybe like 10 to 12 questions or so, and the only directions that you're going to get are going to say to factor completely. I'm not going to say specifically factor using this method or that method. I'm just going to say factor completely. All right, so as always, the first thing that we check for is the GCF. Is there any here? And you should notice that there is, right? Between 12x squared and 48, I can take out a 12. And then once I take out a 12, I'm left with an x squared minus 4. All right, and then from here, we can check, is there anything left on the inside or anything special about the leftover factors that we have? And there is, right? Between x squared and 4, those are both perfect squares. There's a minus in between. This is a difference of squares. So we do have a special case here, right? So when we factor a difference of squares, right, remember 1 gets a plus, 1 gets a minus. It's the square root of the first and square root of the second. So it's going to be an x plus 2 and an x minus 2, and don't forget the 12 as the original GCF that we took out. All right, that's all we have to do for that one. All right, the next one, same exact idea. X to the third minus 16x, the first thing that we always look for is there a GCF? There is one here. We can take out an x, and then you're left with an x squared minus 16. All right, and then you want to check with the factors that you have left over, is there a special case or anything that we could do to factor it more? There is in this case, right? X squared and 16 are both perfect squares. Remember that the difference of squares is going to be two sets of parentheses, one gets a plus, one gets a minus, and it's just going to be the square root of the first, square root of the second. So x plus 4, x minus 4, and I'm going to have that x out front still as the original GCF. All right, so don't forget something as simple as the difference of squares. I see a lot of people all the time. What they do is they maybe write x minus 4 without the other one because they think that we can just square root the first and square root the second. There is another factor here. Another thing that I see some people do is they write x minus 4 twice because they see a minus in the original problem. That's not the formula. One gets a plus, one gets a minus, right? So don't try to make those mistakes. All right. So let's look at the next one. First thing you always want to look, is there a GCF? Between the numbers and the variables, there isn't really a GCF, but I mentioned in the previous lesson that I don't like when the first term is negative. All right, so what I'm going to do is I'm going to pull out of the negative, and then I'm going to make this 9x squared minus 6x plus 1. All right, that just makes it a little bit more apparent about what's going on the inside. Now, if you look on the inside, is there anything special about it? A lot of people wouldn't recognize it, and they would just jump straight to the traditional factoring, the 9 and the plus 1. And they would do 9 times 1, which is 9. Factors of 9, that add to negative 6. It's going to be negative 3 and negative 3. All right, but when they're the exact same thing, you maybe want to check that's something special is happening there. This is actually a perfect square trinomial. We can square root the first, square root the last. All right, so this is going to become 3x and a 1. And if you multiply 3x and 1, I get 3x. And when I double it, I do get 6x. And there's a minus in between, so it's going to be a 3x minus 1 squared. And then don't forget about the minus out front. Now, some people, especially on the test or quiz, maybe not think to check that. So they would have continued doing it this way. And I'll show you that there's absolutely nothing wrong with doing that, right? You can do your slide and divide as before. If I did x minus 3 and x minus 3, right, I have a 9 in front, so I'm going to divide both of these by 9. Simplify as much as you can, so you get x minus 1 over 3, x minus 1 over 3. All right, we still have a fraction, so I'm going to slide these numbers out front. I get a 3x minus 1. And a 3x minus 1, and there was a negative out front in our original factor, so I'm going to write that. And notice that we get the exact same thing, right? They're written differently, but you can write it either way. I don't mind that you write it 3x minus 1, 3x minus 1, or if you write it 3x minus 1 squared, they mean exactly the same thing, right? So in this case, checking for the perfect square trinomial actually would have made it a lot faster. But again, some people maybe not recognize it, especially in the stress of a test or a quiz, maybe not recognize it and do it this way. You do get the exact same answer, but just some things to keep in mind, especially when you get maybe a really big factor. It might be helpful to check right off the bat. All right, so more factoring completely. Another thing that I mentioned in the previous lesson, we don't like to factor when it's not in standard form, right? So we want our polynomial rewritten so that the biggest exponent is first, and it looks like it's this negative 3x to the third. So I'm going to write that first, negative 3x, 3x to the third. And then the next one is going to be a 9x squared, so plus 9x squared. And then my last one's going to be a plus 12x, sorry. And then once again, I don't like when the first term is negative. We also have a GCF between these three terms. So what we can do is take out a negative 3x. And then we're left with an x squared minus 3x minus 4. All right, now you don't want to stop here. You want to check your leftover factors and see if there's anything else we can do. It looks like in this factor right here, we have a trinomial where a equals 1, right? So what we're going to do is we're going to find factors of -4 that add to the middle term, -3. And it looks like it's going to be a -4 and a +1, right? When I add those together, I do get a -3. All right. And this was the easy case, right? When it was just an x squared, this was the easy one where I can just take those numbers, put them in our factors, and that was our answer. All right, so x minus 4, x plus 1, nothing more we need to do to that. Just don't forget about the GCF that we took out originally. All right. Hopefully not too bad so far. You maybe think that you get it, and then you come across something like this one, right? Something like this one maybe not be super obvious right away, but rest assured it can be factored. You just need to be aware of what you're looking for. All right, as always, going through the motions, is this something that has a GCF? It looks like it doesn't, right? Some people might think x squared because they see 2x squareds, but again, the 8 doesn't have one, and also these terms are trapped underneath an exponent, right? But look at what the exponent is. That is an exponent of 2. Anything that's squared is automatically a perfect square, right? You square anything, you get a square out of it. All right, and so the next one, 36x squared, that is also a perfect square. So I have a perfect square and another perfect square, a minus in between, right? Do we know anything special about that? All right, of course we do, right? This is a difference of perfect squares. So I'm going to take the square root of the first, square root of the second. Keep in mind, this is 2 sets of parentheses. One gets a plus and one gets a minus, right? Our first square root is just going to be x squared plus 8. So this is going to be right here. This is an x squared plus 8, x squared plus 8. And then our next one, the square root of 36x squared, is just going to get us a 6x. All right, so that's what's between, the plus and the minus is what's between those two perfect square roots. All right. Now again, just like before, you don't want to stop here. You want to check and see if there's anything left over in the factors that we just found that we can do to factor it even more. All right, and we actually can here, right? Look at what's inside. I have 3 terms and 3 terms, trinomial and a trinomial. Now a trinomial we always want to write in standard form. So x squared plus 6x plus 8. And then the next one, x squared minus 6x plus 8. All right, and then now that it's in standard form, check if it's a trinomial that we can factor, right? There's no GCFs or anything. If there was, we would have taken it out from the beginning. But here, check if there's numbers that multiply to 8 and add to 6, right? So numbers that multiply to 8 add to 6 is going to be 4 and 2. If I add those together, I do get 6. So then this trinomial is going to become an x plus 4 and an x plus 2. All right, same exact thing with this trinomial, right? See if there are factors of 8 that add to -6, and it's going to be -4 and -2. When you combine those, you do get -6. And so we get an x minus 4 and an x minus 2. All right, so that becomes our final answer. Nothing more we can do to that. You always want to ask yourself, though, if there is anything that we can do to it. And there's nothing else, right? Some people might try to confuse themselves and maybe try to keep going even though they can't. Maybe they see that there's an x and a 4 and an x and a 4, an x and a 2 and x and a 2, and maybe try to do some crazy stuff with that. It's only within our factors that we want to try to factor, right? If there's nothing special about the factors by themselves, there's nothing that we have to do, right? So we can leave it alone just like this. This is perfectly fine. All right, so more factoring problems. Again, number 6, the first thing that we want to check, is there a GCF? All right, and it looks like there is none here. Next thing you want to ask, is there any special cases? Well, there's 4 terms here, so no special case, but we know how to factor 4 terms, right? 4 terms, we group the first 2, group the second 2, and we factor by grouping, right? And the GCF of our first group is going to be an x squared. We're left with a 3x plus 1. GCF of our next group is going to be a -9, and we're left with a 3x plus 1. All right, 3x plus 1 matches, so we get a 3x plus 1. And then in our other set of parentheses is going to be an x squared minus 9. Now you never want to stop there. You want to check your factors and see if there's anything else we can do to them. And it looks like there's an x squared minus 9 that we can factor, right? That is a difference of perfect squares. Square root the first, square root the second. 1 gets a plus, 1 gets a minus, right? So this becomes x plus 3. X minus 3, don't forget about the factor that you originally took out, that 3x plus 1. All right, and then there's nothing more you can do to those factors. All right, so then that is all we can do. All right, the last one, as always, check if there's a GCF. It might not be super apparent, but there is a GCF here. Right, I know that this is an example. If you look back at P.4d, when we were doing factoring a GCF, this was the one that confused a lot of people. All right, but all you want to check is are there factors that match, right? And then hopefully we can agree that 2x minus 1 is a factor here, and it's also a factor over here, right? 2x minus 1 squared is the same as 2x minus 1 times 2x minus 1. All right, and hopefully we can agree a factor is just anything that's being multiplied with something else. So we have a matching factor here and a matching factor here, just one of these 2x minus 1s. So if I take that out as a GCF, I'm left with over here a 4x, and I'm left with over here one of my 2x minus 1s. All right, and then left over in parentheses, all we want to do is combine like terms and simplify. So we got a 2x minus 1, 4x and 2x is going to get you 6x minus 1. And then check within your factors, is there anything else we can do to these factors? There is not, so that is our final answer. All right, that concludes all the factoring lessons. Again, the more you do them, the easier they get. Right, just make sure you're looking for the right stuff, right? It's always GCF, special cases, and then traditional factoring with trinomials and four terms, right, with grouping. All right, now some of them get really intense, right? I know that there's some on your homework that might not be super obvious, and then down the line you maybe realize what you have to do, right? But then again, the more you practice, right, this is an essential skill that we're gonna utilize much later throughout the course, right? Even in like the fourth quarter, we're going to be doing factoring even when you might not realize it. All right, so an important skill to have, right? By the end of this, hopefully it'll be like second nature to you.